Okay, so now we're going to insert many sources between here and here. Equally spaced, although it's not absolutely necessary to say that. You can have other restrictions. But so many sources that the distance between the sources is much less than the wavelength. There's just a whole bunch of them. How do the answers to these questions change? Well, how about the answer to the first question?
It's still going to be the same, right?
If these are equally spaced, then for every source on this side, you have a source at equal distance on the other side, or very nearly so. Okay?
What's in the back of it?
So that
Yeah,
your relative phase is still going to be 0, right? Okay? So, many sources. Equal spacing implies relative phase 0. Anywhere on the x-axis. And I'll just say by symmetry. You got to be a little careful about this symmetry, okay? Because if due to the spacing you have one more source on this side than you have on this side, which is certainly possible, then you don't have a source at exactly the same distance on the other side to match up. But if this distance is so small, it's not going to make any significant difference, okay? If these sources are close enough together, it's not going to matter, okay? Now the other thing that I'll say right now is that really what we're talking about in the limit just gives you a continuous source along here, so you're moving this whole thing in phase, okay? And the underlying assumption here that I don't think I've mentioned on, at least on the videos, is that these sources were both in phase, and these sources are all in phase with one another, okay? So now, what's it going to look like along the y-axis?